In this video, we're going to cover regression, and we're going to look at a subset of our larger child nutrition per pupil expenditure data set, just looking at the percentage of free and reduced meals and the total child nutrition per pupil expenditures. It's good practice to start with a scatter plot, so we can insert a scatter plot to take a look at our data. Excel is trying to think for us here. We need to make sure we select the correct data. I'm actually just going to start over the plain graph, or we grab both columns. It probably will create an appropriate graph for us. And we see we do have the free and reduced on the x-axis and the child nutrition per pupil expenditures on the y-axis. And it does look like there is a relationship that's fairly strong, and it's positive and a pretty linear relationship. So the x-axis is the percent free and reduced. The y-axis is the child nutrition PPE total. And I'm going to remove the title on this graph. So if we're just looking at two variables, one response variable, one explanatory variable, the explanatory variable being the percent free and reduced students, we can actually use the trend line in Excel to see the relationship between these two variables. We can ask Excel to display the equation on the chart and the r squared and take a look at this relationship. So I'm going to make this equation a little bit larger. And so we see our equation has an intercept of 111.66 and a slope of 776.23 and an r squared of 0.4759. So the r squared means that approximately 48% of the variation in our total child nutrition per pupil expenditures is explained by the percentage of free and reduced students, and it has a slope of $776.23. And so what that means is on a per percent basis, if we're looking at just moving one unit, so 1% in the percentage of free and reduced students, we're going to see a change in $7.76. We can also look at regression using the data analysis tool pack. So under the data tab, we can go to data analysis, and this is going to give us a little additional detail. So we're going to select regression. And for our input Y range, that's our child nutrition PPE total. For our X range, it's the percentage of free and reduced meals. We do have labels. We want to put this on a new worksheet, and we're going to call that worksheet regression output. And let's also take a look at the residuals and the residual plots. So now here we have our regression output. I need to widen these columns a little bit so we can see all of our information. So again, we see our r squared. We have our number of observations. We have an ANOVA. The overall significance shows that it's high, that our term in the regression is highly significant. It's unlikely that our coefficient is equal to 0. We also have details about our intercept and our one coefficient. In this case, the percentage of free and reduced meals. It's possible in Excel to use multiple variables as explanatory towards the response variable. So it's possible to have multiple coefficients here, each representing a different variable. And we also can see our residuals as well as a plot of those residuals. And so the residuals are just the difference in the actual observations and the predicted based on our regression equation, and then a plot of these residuals, which helps us establish whether or not there's a linear relationship. And we want a fairly random scatter around 0, which leads us to say that the model is represented well by a linear relationship. So this is how we examine and we create regression in Excel. If you're just looking at one explanatory variable, it's possible to use the trend line in Excel, generating just the equation in R squared. And it's also possible to use the data analysis tool pack regression tool to generate more detailed regression output.